Hi, welcome to the third video in our series Programming Autonomous Cars on Unity. Today, we will be looking at how we can implement the multilayered perceptron in the genetic algorithm. So let's go over our game plan. We want to create an evolving neural network so that our cars can navigate any given obstacle course. We also want to create a UI so that the user can create an obstacle course for our cars. Let's focus first on the evolving network first. So before we mentioned the multilayered perceptron with its 3 different layers, input, hidden, and output. We will use this multi-layered perceptron to program the neural network for our cars. So we want our cars to learn based on the path it takes. It needs to be able to navigate through obstacles or walls. So we need some sort of vision that allows our car to learn the obstacle course path. So for our car to see, we will be using raycast, which is part of the Unity physics engine. So essentially, what a raycast does is it casts a ray from an origin point in a direction. If this ray collides with an object, it will return the distance to the collision, telling the user that it has collided. So using raycasts, we can understand how far our car is from an obstacle. Raycasts take in origin and direction vectors, and we can cast them from the car to detect obstacles. For our car, we will generate 5 raycasts coming from the front of the car. These raycasts will act as the input for our neural network. Therefore, we will have 5 inputs for each car, so 5 input nodes. For our neural network, we chose to use a hyperbolic tangent activation function. This activation function transforms values to fit in the range of -1 and 1. So we have 10 hidden neurons, and these hidden neurons are connected to 2 outputs, which control the movement of the car. Depending on these values outputted by the activation function, the output changes. For the output of acceleration, a high output value means that the car should accelerate quickly. A lower output value means the car should accelerate slower. For the second output neuron of rotation, the value determines the degree of rotation for the car at a given instant. Negative values cause the car to turn left, and positive values cause the car to turn right. Based on the outputs, the car will be able to move accordingly. Raycasts will be sent each frame of the game. These raycasts will be cast as input, which will eventually cause the neural network to produce output telling the cars how to move. Next, we have our genetic algorithm, which will help our car to learn the obstacle course. So we need some sort of way of calculating the performance of each car. Before, we discussed a very simple performance indicator, the error, which was equal to the difference in target answer and guess made by Perceptron. However, for our cars, we will need to perform a more complex calculation. The fitness of a car can be determined as the total distance traveled squared. This will be able to determine the performance of the car to a more effective degree. To pick each parent car for the next generation, we have a mating pool, and each car has a probability of being picked. And so the probability of each parent being picked is calculated through the fitness of the car divided by the total fitness of all the cars. Once we have picked the parents, we can use their genes to produce the weights of the children of the next generation of cars. For each child, there will be a 50% chance it uses the weight of its parents' weights, either from one parent or the other parent. However, there's a 7% chance a mutation occurs, which causes a random weight to be generated for the child. So let's explore a bit of Unity. Let's outline some of our objectives and look at how we can achieve them. First, we want to create an obstacle course. Second, create 2 objects, a wall and a car, and assign them their respective properties. Third, we want to implement our neural network with our cars. And fourth, we want to implement a genetic algorithm so that our cars can evolve. Now that we have a general overview, we just need to figure out how to use Unity to achieve these goals. So when you create a game on Unity, you design your game on a scene. You can create a scene in your assets folder. On this scene, we can draw a plane for our cars to exist on. Next, we need to generate our cars. We'll start simple and just draw our cars as a rectangular prism. Add some collision properties so that we will know when it collides with the wall. You can create these 3D objects in the game object panel. The cool thing about Unity is that you can also add scripts to your objects. These scripts can be used to manipulate properties of your object, its movements, and etc. So for our car, we can add our neural network and genetic algorithms to our car through scripts. So that was a simple overview of how we're going to program our car. For our wall, it's incredibly simple to implement. Unity has a built-in collision detection, so the only thing we need to do for our walls is to assign it collision properties. A simple rectangular prism will do, and this rectangular prism can be placed anywhere on the scene to produce our obstacle course. And there we go. That was a pretty simple overview of Unity and how we're going to implement the neural networks. So that will be it for this video. Today we cover a logic implementation of multilayered perceptron and the genetic algorithm, and a general overview of Unity. Next video we will showcase our project and how evolving neural networks can be used to create autonomous cars. Thanks for watching, and if you liked it, please subscribe.